So I guess before I start, a bit of an intro about myself. So I am Sankalp. Hi, everyone. I did my master's back in the day from University of Alberta, and it was a thesis-based master's around recommender systems. And after my graduation, I got a chance to work as an ML researcher with a research lab based out of Alberta. It's called Alberta Machine Intelligence Institute. So I was talking to businesses day in and day out, trying to figure out where exactly within their business process they can use machine learning. And more recently, I joined Diligence sometime early this year in January. And as part of the machine learning team here, we have been working in the past few months to build machine learning powered products in the world of GRC and ESG that Diligent operates in, right? So, and as a result of that, we have built quite a few processes and internal toolings that allows us to build useful products on AWS using sometimes using AWS machine learning services like SageMaker, using some of the open source library as well. So we have done quite a bit to build those useful machine learning services, obviously translating to some business outcomes as well, right? And today's talk is about one such process that we have built and we try to follow as a guideline in any of our machine learning project. So it's about the machine learning project lifecycle framework. And it talks about how do you go about defining steps that involves right from the ideation phase to all the way to production of any machine learning project. So like I said, the talk is going to be fairly non-technical, but it's very useful still. As an ML practitioner, you would know what are the different phases or different steps in the machine learning product development. So it should be very useful. All right, so let's look at what's the agenda or the theme of today's presentation. So we'll look at what exactly the ML journey of a typical organization looks like and sort of contrast it with the traditional software development process. We'll look at the challenges that you will see oftentimes when doing machine learning exploration. So some of the challenges are very unique to ML, and we'll just go over that. And then we'll specifically talk about the core of today's presentation, which is the lifecycle framework. We'll look at what exactly are the different phases or the milestone that makes this framework. And then finally, we'll also look at a case study wherein we will see how to use this lifecycle framework in action. So if that sounds exciting, we can dive right ahead. But before that, at any point in the presentation, if you have any question, you can feel free to interrupt me either through chat or through audio. All is fine. And but I do believe that even at the end of the presentation, we'll have some question answer session as well. All right, so talking about machine learning adoption journey, right? So here we want to think about what exactly, if you were to start a machine learning project tomorrow, what exactly would your adoption journey look like, right? And in order to understand that in a best possible manner, we'll have to look at what exactly is the traditional development process. So this is at a very high level. In any software development lifecycle, you have a set of well-defined processes for creating high-quality software, right? So starting with some business decisions, whether it's based on requirement analysis, planning, software design, all the way to the build phase where you start actually implementing those for deployment and maintenance later on, right? So this is just like a very high level. However, when you're thinking about ML, things aren't as clear and well-defined for the level of every specific details. So in other words, ML exploration is a bit more fuzzy. And that's why, when we think of machine learning, in between these two phases that we just looked at, there is a machine learning exploration phase. So typically, the machine learning journey starts with identifying business use cases. Perhaps you want to automate something. yeah, or perhaps you want to optimize certain business processes. So you would look at those use cases, and you would think about if it is feasible to use machine learning to address those challenges, right? So this journey typically starts with building an ML solution and integrating one into an existing product, deploying it and maintaining it, right? However, to go from the use case discovery to solution development, we really need to understand whether machine learning is viable option or not, right? Because not every time or not every problem is solvable using ML, right? Sometimes even simple rule-based system can help. So you have to make that judgment, or you have to make that assessment. And this is something many of us can overlook given all the false confidence and hype about AI and machine learning in media these days. So it's very easy to miss those. So that's the purpose of machine learning exploration here. This talk is going to be about the exploration phase itself. The essence is how can we generalize this exploration and potentially formalize it into a iterative methodology with very concrete steps that we could follow during the machine learning exploration. So let's look at an example. In this use case, what we are trying to achieve here is automate some kind of a data entry workflow. And this is just going to help us solidify our understanding of what ML exploration is, right? So as I said, the use case is about automating the data entry workflow. And you do that by extracting information from paper forms into some digitized forms, right? So let's assume that this is something that your leadership is asking you to do, right? And but the problem here is you have only a handful of paper forms that are also different to one another, right? So now this becomes very challenging, right? Because in order to build a very robust ML system, contrast to what we have, we may need thousands of digitized versions of such forms, and ideally with a lot of samples in each different category, right? So, this is something that you would assess by looking at data, by looking at fields that you would want to extract out of these paper forms and things like that. And this assessment is not possible without, the ML exploration phase in the middle that allows you to tell, or at least make a good judgment call whether ML is viable to solve something like this or not, right? And this is sort of an example of machine learning exploration where it can be useful to test the uncertainties and evaluate if a machine learning approach is a viable one or not, right? So now that we know at a high level what it takes and how to do machine learning exploration and how is it different from some of the traditional software development, we can look at if I were to summarize what exactly is ML exploration supposed to answer, it would help you answer questions like, can machine learning really address my business problem, right? What is the value that machine learning is adding, right? So if there's an ML outcome, how does it translate to a business outcome, right? And that's just the value add. Do I have the right kind of data, right? Whether the data that I have complements the problem that I'm trying to solve, right? Or what is the feasibility of using machine learning, right? So whether this problem is really solvable by machine learning, sometimes it might be solvable, but you might still not use it if there are simpler ways to do things, right? So all those kind of questions you could get answers to in the ML exploration phase. All right, so now let's look at some of the challenges that comes with machine learning exploration, right? So one of the major challenges in ML exploration is that it's very experimental in nature, right? For those of you who are already familiar with machine learning, you might know that there are so many different parameters that you can tune and optimize for, right? Whether it's the choice of algorithm that you're using, whether it's the kind of data sets that you're using, or you're tuning your parameters, things like that. There are so many different variables that you have to run many experiments before you can find something useful. ML is evolving very fast as well, right? That means that you have lots of methods, especially for novel application that comes directly from research papers or academia, right? So which means that they have not been subjected to thorough testing as well in different kind of situations, data, and domain, right? So what all of that means is that one would need to apply and explore multiple methods to gauge the empirical performance and decide what directions to take next, right? And this makes it pretty much a trial and error approach, right? And such trial and error approaches can pave way to challenges around reproducibility, right? So different team may have different ways, non-standard workflows to arrive at an ML solution. So you would want some kind of a standardized way where you follow a set of steps and process to ultimately reach a solution that you can easily predict, right? So this kind of a life cycle framework helps with that as well, right? And lastly, there are a lot of risk involved in ML exploration. As mentioned before, machine learning requires trying and testing various approaches to figure out what works and what doesn't. So this may easily lead to overlooking a key step during machine learning exploration. And if you're not able to catch it in time, then it increases the risk of failure at some time in the later stage, right? So you want to keep track and identify such key aspects and milestones of ML exploration phase so as to mitigate some of the risks that are involved, right? And the ML lifecycle framework exactly helps with that. So it defines a set of standard modules, in different phases of the project lifecycle, thereby minimizing any risk of overlooking an important aspect of the machine learning development process. So yeah, these are some of the challenges. So now that the stage is set, I guess we can dive right into the project lifecycle. So, before that, let's take a look at where exactly would the lifecycle fit, right? So as we were just looking at this high-level workflow of machine learning exploration, the lifecycle framework is exactly supposed to capture everything that you do within the machine learning exploration phase, right? So this is once we identify a business use case to address using machine learning, and before we go into product development, we should be using the lifecycle framework to capture all the work in a very systematic way during ML exploration, with the end goal to understand the viability of using a machine learning approach to solve a specific business problem. Okay, so let's look at the phases of machine learning lifecycle, right? What are the different phases that makes up the lifecycle framework, right? So we start with problem discovery and scoping, right? So this is where sometimes you may have many business use cases that you would like to address using machine learning, right? And this phase is all about figuring out what exactly are your business priority, discovering that one business problem that you want to prioritize and address using machine learning, right? And in this phase, we have something called a scoping. Scoping is all about, like, once you have a business problem, you scope it out and sort of build a high-level plan for machine learning exploration. So, you would do things like literature review, trying to understand what are the existing research papers that tackle similar problems, or if there are existing industry solutions that work in similar problem settings, right? So you would want to get a know-how of all those before actually planning something to build something on your own, right? So yeah, so that's kind of the first phase here of the lifecycle framework, the problem discovery and scoping. But once you're done with that, the next phase is everything about data, right? So once we have decided to have a machine learning business use case, the framework guides you through different stages of data acquisition and understanding. Like here, you would think about, how do you acquire your data? You would perhaps talk to data teams, domain experts, right? You would try to integrate or align your data points together, right? If you're doing a supervised learning, you would try to generate labels, right? Do some kind of feature engineering, right? So all those kind of steps, and we'll see those steps in a lot more detail when we look at the milestones within each phases. But that's sort of like the idea about the second phase, which is where you want to get your hands dirty with data and prepare data for the downstream machine learning task. So once you have done that, obviously the next phase is the machine learning modeling and evaluation. And this is sort of like the most interesting phase to most people, because this is where you would train a machine learning model based on the data that you prepared in your previous phase, right? And your machine learning, the outcome of this phase is a machine learning model that has some performance level that you would evaluate on some predefined performance metrics. So once you have a machine learning model that works well and has good performance, then you would move to the subsequent and the last phase of the lifecycle framework, which is thinking about deployment and monitoring, right? And this is where thinking about the lean principles, right? What you want to do in the initial part is build something on a very small scale, like your MVP, right? Because all you want to do is get something out of the door that is powered by machine learning, collect all the useful feedback that you can, so that you can go back, iterate, and refine your machine learning model further, right? So that's kind of all the 4 different phases of the machine learning life cycle. I think we can move to the first phase, which is problem discovery and scoping. So here, as I mentioned, we look at identifying business objectives or success criteria, because you would want to know your success criteria even before you start your development process. And during the problem discovery phase itself is where you would want to define a problem, right? So if there are multiple problems, you would want to prioritize them and pick one of the many problems. You would do things like figuring out who are the stakeholders of the project, investigate data sources that are available. So oftentimes, like, the data might be scattered in different places, or data might reside with different teams. So this is where you will talk to different teams and figure out if you have access to data. If not, you will you'll figure out what are the permissions required, things like that. So all such constraints are to be resolved in this phase, right? And like I said, ML project scoping is also an important part of this phase, where you explore research papers or industry solutions that are related or have previously been used to solve similar problems, right? Because it's always good to know since the machine learning world is so fast moving, it's always good to know that what are the existing approaches that people have already tried and tested, right? So it's always good to have a know-how of that. And also, like, understanding your development environment, infrastructure, what are the existing practices that the business is using to solve that problem. So all of this has to be sort of like figured out in phase 1. So the outcome of this phase is a specific business and machine learning problem that has been scoped out to the extent of having some high-level execution plan. So once you have that, you move on to the next phase, and as we just saw, it's all about data acquisition and understanding, right? So what you would do here is gather every data point that is relevant, explore it, and prepare it for the downstream machine learning task, right? So during the data exploration phase, you may have questions like, can I solve my business problem that I identified in the previous phase using the data that I have, right? Or should I go and acquire different data that will help answer my business problem, right? So these are the questions that you will encounter, and you will basically grow in confidence as you explore your data and understand your data good enough, right? Sometimes you may even think about if the data is not favorable, then you may even think about changing the business problem itself so that it complements the data that you have, right? And there could be other data specific questions like, do I have the sufficient data samples with labels, especially like if you're doing supervised learning? What kind of feature engineering or transformations would you require to prepare data for the machine learning task? So all of these questions are supposed to be answered in this phase. And depending on the answers, you may have an outcome wherein the data is now ready or prepared to do some machine learning. So once you have the prepared data, obviously you move on to the next phase. And like I said, this is probably the most interesting for most people, because this is where the actual machine learning model training and evaluation is performed, right? So in this phase, you get a first peek into what I would call a potential promise that ML holds to address the business problem, right? As you're training your model, you will have some idea about model's performance, and thereby it will help you evaluate whether machine learning is really something that can be potentially used to address the business problem, right? And it can be very exploratory, this phase, based on how many different experiments you want to run. As I was saying at the beginning of this call, there are so many different variables, right? You have lots of choice in the algorithms that you use, in different kinds of data sets that you could use, different kind of hyperparameter that you could tune, right? So you can end up, doing a lot here. But again, borrowing from the idea of lean principle, right? One must not, go into the rabbit hole of, just scaling to many hundreds of experiments, right? All you need in this phase is some few good experiments that gives you a good idea whether it's a promising approach to use machine learning for solving the business problem or not, right? And once you have that, then you move on to the next one. So yeah, I mean, again, quick recap of the training, like you have some learning model on a training data. You have some hyperparameters that you want to tune, and you choose an algorithm. And this is where, when you're running multiple experiments, then you will have to do a model selection, which is where, looking at the outcome of each experiment, you would select the best possible model that performs better and hopefully addresses your business problem in a much better way. For evaluation, you obviously would have some predefined metrics. It depends on use case basis. What metrics would you use? Something like a binary classification, you could use simple things like accuracy and F1. But something like if you're trying to do some search recommendation and rankings, then that's where you would use some other metrics like recall or mean average precision and things like that, right? In the evaluation phase, one of the most crucial step here is that you can choose to consolidate your evaluation result and communicate with other stakeholders about the outcomes. And I say it's most important because this is where you would communicate not just the metric scores, but also validate your machine learning models based on the actual predictions that they are making as it would be perceived by the end users, right? So validation step is extremely crucial here because it follows the lean principle idea of focusing on customer validation just to make sure that you are building the right solution, right? If not, then at least it provides you with useful feedback to pivot in a different direction, wherein you want to go back and try some other algorithms or maybe gather some more data and refine it further, right? All right, so assuming we have a trained model as an outcome, we move on to the next and the last phase, which is deployment and maintenance, right? Some people also like to call it ML ops, which is fine as well. But in all of this, in all of this different phases, one must remember that at the end of it all, what you're trying to do is simply build a software that is powered by machine learning, right? So during the initial part of this phase, phase 4, all you care about is building something small scale, building your minimal viable product or the MVP, just to be able to test the waters and get good feedback on, right? Because the MVP would allow you to complete one cycle of the build, measure, learn loop by presenting the leanest version of your machine learning power product to the end users and receiving useful feedback on it. And also, depending on the use case, there may be some other decision makings that is required in this phase, like what exactly is your deployment paradigm look like? For example, are you going to build a batch or an offline prediction system, which is not necessarily real time? Or are you going to use something like, let's say, microservices, right, with REST API to serve online real-time predictions? Or maybe you just want to embed your machine learning model into an edge device, like a mobile device, right? So these are the different deployment paradigms that you'll have to kind of make some business decision on as you're trying to build your MVP. And as your machine learning system matures further, you would need to add some kind of a monitoring in place as well. And this is primarily to detect any drift in model performance, because it can happen that over time, your machine learning model degrades in performance. And this could be due to a variety of reasons, like maybe your operating conditions have changed, or maybe the data that you're receiving now has changed, right? Or maybe we have new novel algorithm that just perform better than what you have built your product on, right? So there could be a variety of reasons why your model can become stale. So it's important to put some kind of monitoring in place for regularly assessing your success metrics, right? Because this would truly indicate over time if your ML outcomes have translated to business outcome, right? So over time, you'd be looking at your success metrics and evaluate what kind of a value add has been done using machine learning. So now that we understand the lifecycle framework and what it looks like, let's try to understand how we can use it to solve real world problems, right? So in essence, what's the expectation of and reality of using something like this, something like the lifecycle framework, right? So it's common to assume that life cycle of any machine learning project would start like this. So you have some business objectives and problem definition, and you move through the milestone within each subsequent phases all the way through deployment and maintenance, right? And that's pretty much how your machine learning project board should look like, right? But the reality is a lot different. Machine learning projects are rarely linear, right? And that's just because the nature of machine learning processes are very exploratory and iterative, right? So oftentimes when you are trying to build something using machine learning, you would encounter some kind of a roadblock during the development process, right? And the roadblock could be due to the variety of reasons, right? Maybe you don't have sufficient data, right? Maybe your choice of algorithm is not good, or maybe you're not getting good results, right? So all of those can be roadblocks over the course of your machine learning development process, at which point you simply have to go back and figure out and maybe redo some of the things to run subsequent experiments in hope for better results, right? So let's assume in this case, while we were performing exploratory data analysis or EDA, we realized that, okay, we don't have enough data points, right? So this is where it's a roadblock for us. If we don't have enough data points, you cannot train good models. So we have to stop our work here and we have to do a life cycle switch and go back to a previous step wherein we figure out how to collect more data samples, right? So as you go about collecting more data samples, you resume working here, and you essentially go through all the subsequent steps, right? Because now you have new data samples, and those need to be processed as well. Those need to be, those need to go through all the subsequent steps as well. So that's where the idea of lifecycle switch comes. And this is just one example, right? When you're actually doing machine learning projects, you would encounter multiple such roadblocks. And each time you'll have to do a life cycle switch wherein you are going back in time and fixing certain things and thereby resuming working on all the subsequent steps, right? And this may happen multiple times before you arrive at a solution that's good enough to be deployed. So that's kind of like how it typically would work in the real world. So what would be some of the common causes for the life cycle switch, right? Well, there could be numerous reasons for that, but some of the most common ones, in my experience, are related to maybe there has been some changes in business objectives since the time you started development, right? Or the data is incorrect or insufficient, right? So as to have a subpar model that's not good enough, right? Or there could be another problem like the machine learning problem does not actually address your business goals, right? Or the exploration goes in the right direction, in the wrong direction, sorry. So there can be like a variety of reasons. And obviously, the most common one is that you do some machine learning and you realize that your results are just not good enough, right? At that point, what do you do, right? So these are some of the things that would really make you think and sort of like go back to the drawing board and try to do things differently the next time and perform all the subsequent steps, run the same set of experiments, hopefully with some tweaks, and expect different but better results. Yeah, I guess like in order to solidify our understanding and see how machine learning project lifecycle is used in real time, let's look at this case study, right? So let's say that we are looking at an energy sector midstream company, right? That is in the business of transportation of oil and gas, right? So the broad business use case here is that the company has all of a sudden they have a use case wherein they want to do something to efficiently utilize their pipeline assets, right? Because they use their pipeline. The pipeline is core of their business, right? All midstream companies, what they do is essentially transport oil and gas from destination A to B, right? And so the broad business problem is they want to efficiently utilize their pipeline assets, make sure that there is less downtime, less malfunctions, and things like that. And the value add that they are looking at is, as a result of addressing this broad business problem, they will have optimal transportation workflows. They will have less downtimes. Their pipelines won't malfunctions. And this is a lot of savings in dollars to the company, right? So the desired outcome, what they are looking at is, if there's a way to identify and remediate any abnormal pipeline operation, then that's great, because they can schedule maintenance right away and hopefully prevent any abnormalities in the pipeline that would shut it down if not taken care of, right? One of the other desired outcomes could be optimal pipeline operations, right? So making sure that they are not underutilizing their pipeline assets. The throughput is good. They are transporting good amount of oil and gas with some optimal flow rate, right? Things like that. So those could be alternative desired outcomes as well. So this is the use case that we are looking at. So now let's try to see if this was a problem that we are trying to address using machine learning, how would we frame the problem and how would we use the lifecycle framework for that, right? So adopting the lifecycle framework for this use case, we obviously start with the business objective and the problem definition. So in this case, what we are looking at is the objective here is increasing the lifetime of pipeline assets, right? And one way to do that is if we could identify abnormal pipeline operations, then we could preempt those abnormalities and make sure those are taken care of in time so that the pipeline doesn't malfunction or it doesn't shut down, right? So this is what the business discovery and scoping phase entails. Once we have a good idea about, okay, what the problem definition is, what the objectives are, and maybe a bit of a scoping as well, then we move to the next phase, which is data acquisition and understanding, right? And the data in this case, for the sake of this example, you can think of all the different kind of sensor measurements, right? Or the readings from the pipeline that you're getting, right? For example, you could have flow rates, vibration, things like pump frequency, RPMs, density of liquid that is being transported. There could be several different data points that you're looking at. And depending on who owns the data, you might have to talk to different teams, get the required access levels and permissions to integrate and align data points, right? And as you are exploring through the data, you realize that you really don't have anything that indicates that a specific data point reflects anomalous pipeline behavior, right? And this is like a major challenge, because if you don't know where exactly in the data is the anomaly, then you have no way to model it, right? So again, we have hit a roadblock here, as you can see, and it's imperative that we do some kind of a life cycle switch. In this case, the potential action would be, I would go back to my domain experts, which in this case could be pipeline operators or the control room operators, show them the data and ask them to help identify data points which reflect anomalous behavior, right? So hopefully with that done, we have labeled anomalies in the data, right? So once all the data is good, we move on to the next phase, which is the modeling and evaluation. So let's say this is where you try to define some domain specific features, you run your experiments, do different kind of modeling, everything seems fine, and you move into the final phase, which is, as we just saw, defining what exactly your MVP is, defining what your deployment paradigm is. For the sake of this example, I would assume that you would want to predict in advance if there is an imminent failure or if there's an imminent abnormality in pipeline operations, right? So that you can identify that, and you can notify the ground operators so that they can do some kind of maintenance to preempt those failures, right? So those kind of things have to be like figured out in this phase. Integration with product is another important part of it, right? So as a control room operator, let's say if I'm using some kind of a dashboard that gives me some kind of status about how pipeline is running, this is exactly where I would want the ML predictions to go, right? So as they keep a tab on if the ML is predicting the operations are normal versus abnormal, and they can take relevant actions from there on, right? So this is all at the final phase, and if everything is defined, you sort of like monitor your machine learning recommendations over time and compare it to the success criteria. Like, have you been able, as a result of building this machine learning solution, were you able to prevent failures, right? Were you able to prevent any abnormalities or downtimes, right? And that is something that you would compare over the previous year when you have been using pipeline without machine learning, so as to gauge what kind of a value add you're getting out of it, right? And that's the success right there. So yeah, I mean, that was the use case for how you would typically go about using this life cycle framework in a real setting for a real world problem. So then, like, one of the obvious questions that people tend to ask is, okay, this is all good, but do we have any existing machine learning frameworks that are very similar in nature, right? And the answer is yes. There are several platforms such as Microsoft Team Data Science Project, or TDSP, MLflow, TFX from Google, or FD Learner from Facebook. And all of these provide platform support to manage their ML development pipelines, right? All of these are really great tools that tackle most of the challenges within the ML development process. However, like most of these tools are also very specific to the teams and the development workflow that each of these companies follow, right? And an example for that would be Uber's machine learning platform, which they call Michelangelo, right? As you can see, throughout different phases, they have very specific components, tools, and technology that they are using for all the phases, right? From getting the data to training their model in a batch offline setting to deploying and making predictions in real time, right? So this is very specific to the platform, teams, tools, and technologies at Uber. But yeah, obviously this does the job for them pretty well as well. So machine learning framework is somewhat different, right, from these tools in the way that we want to have some kind of framework that is abstract enough that it can be adopted in any development environment, right? We primarily work with AWS, right? So we would like to, certainly we have used this framework within our internal projects to build products on AWS. So that's like the level of abstraction that we want, that it's flexible enough to use in any environment. And at the same time, we want to have something that is that has concrete phases and milestones to make sure that we are not overlooking any key steps in the ML development process. So, just to summarize, like a few takeaways or a few of the things that makes the lifecycle framework different is that it's technology agnostic. It tries to decouple the ML exploration phase from product development. It provides, phase-wise process modules with steps and milestones so as to make sure that you're not missing out on some key aspect of the ML development process. It's, like I said, it's abstract enough to be flexible in terms of using it within any dev environment. And it's certainly detailed enough as well in terms of the phases and milestones so as to capture majority of the machine learning concerns during the development process. So yeah, that's about it.
Thank you everyone for coming. Thank you, Sankalp, for this amazing presentation. We definitely had a lot of fun. And see you in December. We are going to talk about tools for software engineers, and we'll scale our event very, very soon.